guys, Mrs. Brumwell here. This video is going to go over how to simplify radicals. Some of you may have seen this before, some of you this might be totally new, that's okay. We're going to use this all throughout the year, but this is actually an algebra skill, and you're going to use this in math classes beyond here as well. Okay, so first we're just going to review what a radical is, and we're going to just focus on this class on square roots. Okay, so that's what this symbol is. This is a radical symbol. This is asking the square root of 49. So what a square root is a number times itself that equals what's underneath. So in this case, what number times itself equals 49? 7. What number times itself equals 9? 3. What number times itself equals 225? 15. And what number times itself equals 121? So I knew all these by memory, but if you don't know one, let's say I don't know the square root of 121 and you're trying to use your calculator, I'm going to show that to you on 2 different calculators, how to do the square root. Okay, so if I want to find the square root, I'm going to hit second and then the x squared button, because if you can see, it's really little, but that little tiny square root in green, by hitting the second button, that allows me to choose the option above the button. So second x squared, and then I type in 121 and hit equals. So the square root of 121 is 11. Okay, how you do it on a graphing calculator like this, it's the same exact steps. Second, and then x squared, and then you type in the number you want to find the square root of, and then hit equals, and you get the same thing. Okay, so that symbol again is called a radical. The thing underneath is called a radicand. It can be a number or it could be an expression. A perfect square is a number that has an integer square root. So a number whose square root is a whole number. So these were all examples of perfect squares. 49 was a perfect square because we got a nice whole number answer. Where if I wanted like the square root of 10, there's no number times itself that equals 10. That's a nice whole number. It's going to be a decimal, for example. Okay. Yeah, okay. So we are going to use a couple rules here to help us simplify radicals. And so whenever I multiply radicals, I can actually combine those under the same square root, or if it's more convenient, I can break them apart. So this works both ways. So multiplication, we can combine under one radical, or we can split it into separate radicals. Okay, so what is this process of simplifying radical? Why can't I just type all radicals into my calculator and have that figured out? Well, we can use the calculator to help us. But for example, if I wanted to do let's do this first example, square root of 20. So if I typed in square root of 20 on my calculator, I get, oh, sorry, I don't want that plus sign in there. Okay, I get this decimal that goes on forever without a pattern. That's called an irrational number. And your calculator only goes out this many places. That's actually not the end of the answer. It goes on forever. So your calculator is rounding to this place. So technically, this is not an exact answer. It is rounded. So a simplified radical is not giving it as a decimal. It is giving it still an exact form. So what that means is we are going to make sure that what's underneath the radical does not have any perfect square factors. Okay, so no perfect square factors remain in the radicand. So again, the radicand is the piece that's underneath the radical. Okay, so how do we do that? Well, let's go back to this example, square root of 20. And I'm actually going to zoom in a little bit here, you guys. All right, square root of 20. Okay, so I'm going to show you guys two methods. This first method is actually how I learned when I was a student. And I gotta tell you, it's not my favorite one now that I've learned another method, but I'm gonna show it to you because some of you guys might like it. This method is great if you know your perfect squares from memory. You know 1, 4, 9, 16, 25, 49, 64, 81, 100, 121, 144, you know those numbers are perfect squares. And remember, perfect square means their square root is a whole number. So 9 is a perfect square because its square root is 3. 144 is a perfect square because its square root is 12. So if you know those by heart, this is a great method. So square root of 20, so what I'm going to try and do is I'm actually going to use this rule, is I'm going to break 20 into two different numbers that multiply to be 20. Now I want to strategically pick those numbers so that one of them is a perfect square. And I actually want to try and pick the biggest perfect square that I can. So perfect squares method is determine largest perfect square factor. Okay, so for 20, the numbers that go into 20 that contain a perfect square are 4 and 5. 4 is the largest perfect square that goes into 20. So I'm going to rewrite square root of 20 as 4 times 5, right? And I can do this with multiplication. I can break it into two different radicals. Well, the reason why that's helpful is I know the square root of 4. That's a perfect square. Square root of 4 is just 2. Square root of 5 is not a perfect square. We're going to leave it like this. This is a simplified radical. We pulled out this perfect square factor and simplified it to just 2. And then anything that's not a perfect square stays underneath the radicand. This is an exact form. We're not rounding. We don't have an ugly decimal. This is considered exact, but it's simplified because we pulled out any perfect square factors that we could. Okay, let's try 75. So 75 is the same as 3 times 25. 25 is a perfect square. The square root of 25 is 5. So that is the simplified radical. Okay, now this one, we already have a 2 out front. That's okay. We're going to multiply that 2 because this is 2 times the square root of 18 is how I'm going to read that. So I'm going to keep that 2 times out front, but I'm going to do what I just did over here. I'm going to break 18 into a perfect square factor. So 9 is a perfect square that goes into 18, so it's the same as 9 times 2. Notice, again, I'm keeping them both under the square root. Square root of 9 is 3, and then square root of 2 stays here. Okay, so now these are both numbers outside the radical. We can multiply those. 2 times 3 is 6, and then the square root of 2 will stay there. Okay, so that is the perfect squares method. We determine the largest perfect square factor. Rewrite as multiplication of 2 radicals and simplify. Okay, so we rewrote all of these as the multiplication of 2 radicals. One of the radicals was the largest perfect square factor. Okay. Now, this other method is called the prime factorization method. This method is great if you don't necessarily have all your perfect squares memorized. And this is also great if you have like a larger number. I think that this method is really helpful as well. Okay, so in this method, you don't have to think of a perfect square. You just have to think of any 2 numbers that multiply to be what's underneath. Okay, so 60, the numbers that come to mind for me are 6 and 10. You could do 2 and 30. You could do 4 and 15. It doesn't matter. You can do any that you want. Now, I'm going to pick 6 and 10. Okay, so prime factorization means I'm going to break 60 down to its prime factors. Prime is a number that divides only by itself and 1. So 6 can be divided by more than that. It could be divided by 2 and 3. Now 2 can only be divided by 2 and 1, so 2 is a prime factor. 3 can only be divided by 3 and 1, so it's a prime factor. So we're done with this factor tree on this side. 10, we're going to do the same thing. 10 is not prime. It can be broken down into 2 and 5. 2 and 5 are both prime. So we broke it down as far as we could into numbers that are prime, can only be divided by 1 and themselves. So once we break it down, these numbers that we've broken it down to still multiply to be 60. 2 times 3 times 2 times 5 is 60. So I'm actually going to rewrite this out for a second. This is the same, 60 is the same as 2 times 2 times 3 times 5. Now, why is that helpful? Well, 2 times 2 is the same as 2 squared times 3 times 5. Well, if I were to break this into 2 separate roots, I'm going to kind of do this up here, you guys. So I've got 2 squared times square root of 3 times square root of 5. Okay, 2 squared. The square root and squaring are opposites. They cancel each other out. So we're left with 2. I can't do that with these. I don't have any squared, so I can put those back together and say 15. Okay? Another way people do this is anytime so basically what I'm looking for is, do I have anything squared? Well, that happens when I have 2 of the same thing being multiplied. So right here, I had a 2 and a 2. That pair, right? 2 times 2 is 2 squared. Taking the square root of something squared is 2. So whatever I have a pair of is a number that's going to come out front. Anything that doesn't have a pair multiplies back together underneath. So that's kind of the simpler way, is just look for a pair of numbers. So let's try this with 180. Okay, so I'm going to break it down. Okay, I'm going to do 18 and 10. Okay, 18, I can keep going with that. I can do 9 and 2. 10, I can do 2 and 5. Those are prime. 2's prime. 9's not prime. I can keep going with 9. Okay, so once I've broken it down to its prime factors, I'm not going to use these numbers anymore. So these are the prime factors. 3, 3, 2, 2, 5. So again, this is the same as, I have 2 3's, so that's the same as 3 squared. 2 2's is 2 squared. And then 5 does not have a pair. So those pairs, the squaring and square root cancel, and it just becomes a regular 3 times a regular 2, and then the 5 did not have a pair. So 3 times 2 is 6, so this one is 6 times the square root of 5. Okay, 3,000. Okay, so here's kind of a cool thing with anything with a bunch of zeros. This is the same as 3 times 1,000, or 30 times 100, or 300 times 10. So you can kind of like shift the zeros to either side. I'm going to do 30 and 10. Actually, 30 and 100, that's what I meant. And the reason I like that is because 100 is a perfect square. So I have a pair right there. So even though I could break 10s down further, I already have 10 squared. So as soon as I have a pair, I don't need to keep going with those. 30, though, can break into 3 and 10, 2 and 5. So I'm not going to use those because I broke them down further. So there's no pairs with those, right? My only pair was with the 10. So the 10 squared, square root of 10 squared just becomes a regular 10. And underneath we have 3 times 2 times 5. That none of those had a pair. So that's going to give us 10 times the square root of 30. Okay, so that is how you simplify radicals. We're pulling out any perfect square factors. We can do that from the perfect squares method or this prime factorization method, which is create a factor tree and look for pairs. Okay, that's it for this video, guys. Thanks for watching.